A light inelastic string connects two boxes of mass 6 kg and 3 kg respectively. The two boxes are pulled up an inclined plane that makes an angle of 30 degrees with the horizontal, with a force of magnitude F. The kinetic frictional force experienced by 3 kg box and 6 kg box is 5 Newton and 8 Newton respectively. So the respectively part, this just simply means that the first force to appear correspond with the first mass, and then the second force correspond with the second mass, right? So in other words, don't do vice versa. The first mass to be measured correspond with the first force, friction force to be measured. That's what the respective part comes about. So now the first question says that state Newton's second law of motion in words. So in other words, the Newton's second law definition lays in this formula, F is equal to ma. So but you are told that you have to explain this in words, not what I'm doing here. I just want to give you a hint as to something that will assist in remembering this law. So it says if the net force act or is applied on the object will accelerate in the direction of the resultant force, or in the direction of the net force, with the acceleration that is directly proportional to the force. Acceleration being directly proportional to the force, right? And inversely proportional to the mass of the object. So that's what Newton's second law says. So now the second question says, draw labeled free body diagram indicating all forces acting on the 6 kg box as it moves up the incline. So let's check the 6 kg. We are told that there is a frictional force. We know that we have a tension force. We know that we have the normal force. And we know that we also have the gravitational force. So these are the forces that are acting on the 6 kg block. So you can just write a circle here or a dot here like this. After writing this dot, you will have the frictional force, and right away straight like this, you will also have the force, which is the tension force, and then you will have the normal force like this, and then you will also lastly have the gravitational force, or the force of gravity. Yeah, so it's like this, and then you can label them. So this can be the tension force, this one will be the normal force, and then this one will be the frictional force, and this one will be the force of gravity, or the force due to gravity, Fg. Yeah, so that is it. So the another question says, or question 2.3 says, the boxes accelerate up the inclined plane at a 4 meter per second squared. By applying Newton's second law of motion separate to each of the boxes, calculate the magnitude of the force that must be applied. So we are given the acceleration here. The acceleration is given. So let me get my paper ready so that I can write this. So let's start with for a 6 kg block or box. we have this. Look, we have the incline, and then the incline with the box, and we have the angle here, which is 30°. So this is the angle here, and then we can draw another triangle like this, having a certain angle, and this angle is the same as this angle here. So we have this force here, which is a force parallel with the incline here. In other words, this one here is the force of gravity, and then this one here is the force. You can see that this line is parallel with the incline, right? So that's why I indicated with FG parallel, and it's equals to mg sine 30°. So it's equal to mg sine of this angle. In other words, if this angle was 40, we're going to put 40 here. If it was 15, we're going to replace this 30 with 15. So it depends on the angle that we are given, right? This time is 30. That's why we say it's equal to. That's why we can say it's equal to mg sine 30. So from Newton's second law, we know that other than actually before we even go to Newton's second law, we know that we have the frictional force. This is the friction force. We have the forward force. This is the forward force here, and we also have the normal force. And Newton's second law, we have force, or F net is equal to ma, which is mass multiplied by acceleration. Already we are given that acceleration is equal to 4 meters per second, and we are looking for the force that has been applied, and we have to work this separately. So as far as the 6 kilogram box is concerned, we are going to find the forces that are responsible, especially when this 6 kilogram box was moving up the incline. If you check, this force here was responsible, right? This mg sine theta, or this fg parallel, it was responsible. And then this friction force was also responsible because it was against the motion, right? So the normal force in this time, in this case, is not responsible in pulling this backwards or forward. In other words, the force that were responsible are 1, 2, 3. In other words, they were against the tension. Tension was going up, but friction and this one fg parallel was pulling backwards. So in other words, F net is just the overall forces that was working. So the force that was pulling up, which one was pulling up, is the tension force. So let me write the tension force here. It's tension minus friction force minus the Fg parallel. This will be equal to mass multiplied by acceleration. So it's going to be tension, frictional force we are given, it's 8, minus Fg parallel we know is equal to Fmg sine 30. So in other words, we can write mg sine 30, which is mg, the mass is 6, multiplied by gravity is 9,8 sine 30. So we can even put brackets so that we don't have to confuse ourselves, and you can even put multiply here so that it will be easier to see and to follow, right? Yeah, like this. And this should be equals to 6, because mass is 6, acceleration is 4, right? So we can press a calculator and find the value of t. So we'll write here on this page. This implies that t is equal to 61,4 Newton. So now we can go and do the same with the 3 kilogram block. Let's erase this one and go and work with the 3 kilogram block. So this is for 3 kilogram. For 3 kilogram now we have force. If you check, this one will be the force applied. This one will be the tension. We also have the friction other than the tension, and we also have the FG parallel here. This is for 3 kilogram one. So if you check, it will be it will be force applied minus tension minus friction force and also minus FG parallel. This should be equal to MA. So let's simplify it and substitute. We have F minus tension. We have calculated it already. We know it's 61,4 minus friction force of 3 kilogram box. It's 5 Newton is given. Is this one here? Is given here. And then minus Fg parallel is the same as mg sin theta, and the mass is 3 kilogram multiplied by g, which is gravity, is 9,8 sine of 30 degree. Close brackets. This is equal to the mass multiplied by acceleration. Mass is 3 kilogram multiplied by acceleration, which is 4 meter per second. So after pressing a calculator, we find that the value of the force applied is equals to 93,1 Newton. So that is it. So the last question says, let's see the last question. How will the kinetic friction experienced by the box be affected if the angle between the inclined plane and the horizontal increases? Write down only increases, decreases, remain the same, and also give a reason for the answer. So the correct answer will be decrease, because the normal force will have also decreased. So that's the answer. So thank you for watching the video. Don't forget to subscribe to my channel and hit the notification button so that you will be notified every time I post a video.